Welcome back to the Structured Cabling Lecture Series, lesson number 4. Today we will cover categories of cables. If you haven't seen my previous lectures, I will post a link in the description for the playlist. Remember from the previous lecture that I have introduced you to the categorization of cables. Those include the Cat 1 going all the way up to Cat 8, and in the future there will be more categories added to it. I mentioned to you that the category 1, 2, and 3 is mostly used in the telecommunication industry, but at the category 3 level, 10BASE-T Ethernet came into effect, which is giving us about 10 megabyte per second data rate. And then Cat 4 is a special cable that is used in the token ring system that basically went out of favor very soon after it was introduced later that decade. We have now Cat 5 and Cat 5e, Cat 6, Cat 6a, Cat 7, 7a, and 8 in the market. What very common modern day in our network system is the Cat 5, Cat 5e, Cat 6, and Cat 6a. So from Cat 5 to Cat 6a, these couple of items right here, these categories are the most common cables used today in the networking industry. Again, recall from my previous lecture, the reason why we have these categories, that we have used these categories to standardize the minimum bandwidth and data rates as well as the maximum distance associated with it. So it will, for example, if you go to any manufacturer and buy a category 5e cable, you are expected to have the maximum data rate of 1 gigabyte per second with a bandwidth of maximum 100 megahertz with up to 100 meters. So what this categorization is doing is giving us a guaranteed of minimum standards associated with each of these types. So today I'm going to cover a few items, and one of them would be buying Ethernet cable for your network. And what we need to think about when you are trying to buy a cable is the speed or data rate which the cable can support, the shielding, cable length or distance, installation location, cable styles, and cost versus benefit analysis. So I just corrected a spelling mistake. This should read cable style. So in the next few slides, I will go over some of these items in depth. But for now, I'm going to give you a brief overview of each one of them. And I will not cover everything in detail in this lecture, just to keep the lecture short. For example, cable style is basically, the style of cable you use. So there's not much to discuss there. So I will basically briefly discuss that over and move forward. Okay. So when it comes to my speed, which is also sometimes, associated with what we call the data rate, which is associated with that anyway. And the speed of the cable refers to the amount of data it can transmit per second. So for example, when we say 100 megabyte per second, that basically means the cable can transmit 100 million bits of data every second. In commercial network, speed is usually dictated by the equipment that you will be connecting to these cables. Like for example, a network switch with a gigabit Ethernet ports will support up 2000 megabyte per second. And even if you have a cable that may be supporting better data rates, that will create a bottleneck, for example, right? So for example, if you have fiber optics cables everywhere, but your main switches in the main distribution network is only 100 or 1000 megabyte per second, is not going to go any further than that, right? So keep that in mind. So that's the speed of which the cable can support is important, but just because of you are buying a better speed rated cable doesn't mean your network going to be inherently faster. So in home settings, when you're choosing cables, you need to think about the internet connection and type of connection that you need, how far that you're gonna pull these cables between different endpoints or different intermediate devices such as switches and routers within your house. So again, I'm not going to go into detail right now, but I will discuss a little bit more in depth in the next few slides. The next thing is shielding. So some Ethernet cables are shielded to protect cables from electromagnetic interference, and some are not. Some shielding have also environmental protection, which I will discuss in next few slides. Same with the cable length and distance. It has to do with how far the cable can be put between either end device and an intermediary device such as a switch and a desktop computer, or in between intermediary devices such as between two switches, for example, before the signal start to degrade. So how far the distance that the cable can handle. Installation location, whether you're going to put the cable inside the building or outside the building, matters. That will define what type of cable you would purchase. Cable style, as I mentioned, is a very minor detail, but it sometimes does matter, because there are some Cat5e, Cat6 and Cat6e cables that may have a certain style. Like for example, Cat5e, you can get a flat cable where all the wires are flat, so that it easily can be rollable or put it inside some kind of a enclosure, for example, compared to the regular Cat5e cables that you see, which is a rounded jacket. So that's what I meant by cable style. And finally, cost versus benefit analysis. So if you are working for a small business or whether it's a large corporation, you need to think about the cost associated with buying these cables. Again, some of these items I'm going to cover in the next few minutes, and except there's some things like this cable style. So recall from my previous lecture, the cable shielding, the information that we went over. We discussed about the UTP, STP, FTP, and I briefly went over what UTP, SUTP, and SFTP means. And here is a summary of that. So this is where the cable shielding become something that you should be aware of as a cable installer or a structured cabling engineer. So for example, UTP would have a twisted pairs like this, and you have a cable jacket, and between these twisted pairs or among these cables there is no separation. But when you come to the point STP, the cost is a little bit higher, but now you have a shielded shield outside plus a shield between you have a jacket outside, which is kind of a shield, and then you have a shielding between each of these pairs. So each of these pairs are separated with a shield. With FTP, we will have foil instead of just a plastic or some other form of shielding to separate these things, which will give you a better electromagnetic separation in many situations. And then FUTP will have a jacket outside, but right after the jacket you will have a foil right beneath it. Then you have SUTP. Again, in this one we have a cable jacket outside. Then we're gonna have a braided shield in this case, which are typically used also in outside environments, and that's why we use that type of cable. And when you have SFTP, we also have a cross divider like this. So in addition to foil shields between each twisted pair, in addition to the cable jacket, and also another braided shield out right beneath it, we also have a actual divider, like a plastic divider between each of these pairs. Again, the cost going to go up as you move from this end to this end of this diagram, but there are use case scenario that you really need to use this kind of a high-end cable for your cable installation purposes. Again, I'm not going to go into in-depth analysis of what are each of these scenarios are in this lecture. I'm just introducing you right now. I will go over that maybe in future lectures if we have time to cover those items. But keep in mind, what really important in this slide is that there are these different types of shielding, cable shielding, and they are denoted by like UTP, STP, FTP, etc., and you need to know what they are in a general sense as a cable installer. The next topic we're gonna discuss is the cable length. So the maximum length of a Cat5e or Cat6 Ethernet cable is about 295 feet, which is about 90 meters. how we calculate that 295 feet or 90 meter is that we also accounted for up to about 16 feet, which is about 5 meters of patch cables on the either end of the cable. So for what I mean is that the Cat5e and Cat6 is actually rated for 100 meters, but we typically don't go more than 90 meters between devices, between endpoints, because we may want to put a patch cable on the either side. Like for example, we have a wall socket here, and let's say there's a switch in between, and we have a wall socket in here. We can put 100 meters between the switch and the wall socket, and the switch and the wall socket. But if there is no switch or intermediary devices in here, it's going from socket to socket. So let's say this is a patch panel right here, and this is a wall plate right here. We typically only go maximum up to 90 meters. Why? Because from the patch panel to your router or a switch, we can put up to 5 meters of patch cable, and from the wall plate to your device, we can put up to about 5 meters or 16 feet of patch cable. Hence, the total add up going to end up with 100 meters or less. If you put a cable or the cable distance between endpoints more than 100 meters, if you put a cable more than 100 meters between your end devices, or between your end device and an intermediary device such as a router and a laptop computer, what will happen is that the signal attenuation. So just because of you have a Cat6 cable or a Cat5e cable that is more than 100 meters, a little over 100 meters, let's say 105 meters long cable, doesn't mean you suddenly lose your internet. It doesn't mean you suddenly have a network connection issues. But what most likely going to happen is signal attenuation. So basically, longer the cable, more the signal going to degrade, and with certain conditions, even under 90 meters, you may, or even under 100 meters, you may experience some signal attenuation, such as due to electromagnetic interference, right? So if you have 110, 115, 120 meter cable, Cat5e cable, you may have network connection, you may be able to access your network drives and everything, but maybe the speed at which you can download data from your network connection may be slow due to signal attenuation. If you have wireless access points that are connected at the end of the 110 meter cable of Cat5e, that may create intermittent network connectivity losses, that may create a situation where your access point go out of service once in a while as a result of it. For example, there was a situation that I've been told where they put a Cat5e cable about 110 meters to an access point AP, and during the night and during the early morning hours, the access point works just fine. But during the day, when a lot of people in the office are connecting to the wireless network, the access point go out of service. So it loses connectivity. So why is that happen? Well, because that cable between the access point and the intermediary device, which is a switch or a router, is more than 100 meters, about 110 meters. So during the early morning hours or late at night, nothing might much happen because there are not enough congestion in the system to cause a problem. But during the daytime, when everybody in the office trying to connect to that access point, the issues start to pop up, and the reason is the signal attenuation. Now, if you have a cable that is like 200 meters long and it is a Cat5e cable, you may also even completely lose the signal at all, completely, and you may not get the connection at all. But if you have like 110, 120 meters, which is just above the 100 meter, maximum, you may have signal attenuation that will intermittent, for example. So keep that in mind. The next thing I'm going to briefly discuss is the cable style. So there are cable styles that are called the slim or ultra slim cables. Those are cables that have diameter that are typically 30 to 50% less than that of the standard Cat6 cable or Cat5e cable. And those are manufactured from a smaller gauge copper wire, and 4-pair standard cables increase standard cable increases airflow in crowded equipment racks, which helps keep the component cool and functioning properly. So basically, why would you want to use a ultra slim or slim cables? Maybe because your network closet have way too many wires, and your network engineer, or if you are a network engineer or a network administrator, you're trying to keep those cables as tightly as possible. Another reason why somebody might go with the slim or ultra slim cables is to aesthetics purposes. So if you have, for example, a TV with a network connection hooked up to a crowded area, let's say an airport, for example, that displays the flights coming in, you may not want to put a huge thick cables onto it give it a network connection. You may want a very slim cable that goes through the ceiling tiles, goes through the tube that is connecting to the roof of the ceiling tiles, for example. In that case also you might use a slim cable. Flat cables, so basically although they are not common choice, the flat cables have some unique characteristic that makes them beneficial in certain applications. Flat cables have good heat dissipation, for example, and more evenly distribute the physical loads on the cable. So they also have the ability to bend easily, as opposed to a rounder cable. So the flat cables are some of the cables that sometimes comes in the box with some of the switches and routers, like the consumer switches and consumer routers. Basically all the cables going to be very flat. The difference between a flat cable and a slim or ultra slim cable, slim and ultra slim cable also have a change in gauge of the wire. Flat and ultra slim cables are pretty similar to each other in that, in a sense, they are not round cable. They are not like tube like structure. They have a flat surfaces. So that's what it mean by flat cable. Actually, let me show you some pictures. Here you go. I post the video and got a picture of a flat Cat7 cable from the Amazon website. So as you can see, this cable is very flat. So the cable that you have seen oftentimes is the round cables, and this is an example of a flat cable. So that is good for like tight spaces and keeping things neat, etc., etc. So I should have put this picture earlier on, so I just added right now so that you can see that what I'm talking about. Then you need to consider things like solid core cables versus stranded cables. So in network cables, basically when you look at the type of network cables that you can buy, there are two types of cores that you can find. One called the stranded, the other one called the solid wire format. As the name suggests, the solid core cables are the one that use solid copper wire for each of these conductors. For example, each of these conductors will have a solid copper wire inside right there. I have introduced this concept in my previous lectures already, so I'm not going to go into depth of that, but what you need to understand is the solid conductor cables are typically used in infrastructure level. In other words, when you are putting wires across the ceiling tiles, or you're putting wires across from wall plate to the switch or router, you typically use the solid core cables, as opposed to stranded core cables are typically used for patch cables, because stranded cables are more flexible as opposed to solid wire cable. But solid wire cables are more long lasting in the spaces where you don't need that flexibility. For example, for horizontal cables runs, in other words, it is suitable to use solid core cables. And also the research shows that when we have power over Ethernet or outdoor applications, the solid core cables tend to last longer and performs better as opposed to stranded cables. So what you need to remember is, for all your patch panel needs, you typically go with the stranded core cables, while infrastructure needs, such as putting a power over Ethernet, let's say access point, you typically use the solid core cable inside the ceiling tiles, for example. So that's what you need to understand. Again, I already have covered that, so I'm not going to go into any more depth. And the next one is the armored cable. So the armored cables have a outer jacket that are armored to basically resist environmental conditions, as well as to provide some protection from other factors, including in environments where you may not need to put a cable where it may be exposed to extreme factors. So applications where location is potentially involve maybe crushing or a bending of your cable. For let's say you have a network cable that you need to put it into an industrial application where some kind of a device is moving. Let's say it is a manufacturing device, and the 3D printer or this manufacturing arm is always moving up and down and to side. I would typically use an armored network cable in that situation, because that will protect that cable from bending too much and breaking it off, and also will protect it from environmental elements. Also, if I have to put cables in places like sawmills, for example, where there's sort of dust and heat and everything, I would also prefer to go with armored cable in that kind of environment. So any kind of a environment where it is harsh environment conditions, industrial applications such as the warehouses, I would use armored cable. In fact, Amazon is currently building a warehouse in near Alberta, southern Alberta, and they're actually using armored cable for everything inside the building. I actually seen that on somewhere on the news. So there you go. That's an real world application of why somebody would pay the money to buy armored cable, because it gives all that protection, extra protection for cable. So keep in mind, when I'm discussing about solid core cables, we actually talking about what the cable inside. These are these wires inside, not the cable itself, but actually we are talking about the wires inside. But when we are talking about armored cable, we are talking about the external sheath, the external protection that we are talking here. So keep that in mind as well. So what I mean is that you can have armored cable that are solid core, you can have armored cable that are stranded core. So keep that in mind. So those are combinations you could get. Next thing we want to discuss is the gauge. Gauge is not only important to networking and network engineering, but also important in electrical applications and electronic applications as well. So if you have taken any high school physics classes in Canada, you already know what a gauge is. So this is a basic fundamental concept every high school graduate should know. Even younger than that nowadays, I don't know how the education system has changed. If you have taken any high school physics classes, even science classes, we know that the smaller the American wire gauge, also known as the AWG, the bigger the conductor diameter. So in other words, if I have a gauge 20 wire, that actually going to have a bigger diameter than gauge 28 wire. So it is opposite. It is 1 over. You need to think about 1 over, opposite. So smaller the gauge, the bigger the conductor diameter. Keep that in mind. So the conductor diameter size is measured in American wire gauge, also known as AWG, or we sometimes call just gauge. And that is an imperial unit, and that is mostly used in Canada and the United States, but also used all over the world now because of the, remember from our first lecture, because of the popularization of this kind of standardization by companies like AT&T and Bell Laboratories. Those happen to be American companies. Therefore, AWG gauge is being used almost all, everywhere in the world. However, there are also square millimeters in use, which are called square millimeter. And the conversion between the AWG and the square millimeter is not always 1-to-1. In other words, the gauge of 20 doesn't always translate into a specific number in the square millimeters. So there is some conversion factors you need to take into account. Typical sizes, what you need to keep in mind is that for data communication is gauge 20 all the way to gauge 28. Keep in mind, gauge 20 have a bigger diameter conductor compared to gauge 28 have a smaller, tinier diameter conductor. And for electrical, we have gauge 18, 16, 14, and 12 for both residential and automotive electrical items. So if you have a vehicle, those vehicles will have gauge 18, 16, 14, or 12, and same in the home uses as well. Keep in mind again, data communication use a higher, bigger gauge compared to a electrical. Why? Because the electrical wires need to be more bigger in diameter to support that electrical conductivity, as opposed to data communication, we probably dealing with less than 50 volts or around 50, 60 volts maximum, as opposed to this is 250 volts, 110 volts with a high amperage as well. Data communication is very low amperage, so we can get away with using higher gauge wires, which result in lower diameter wires, as opposed to lower gauge wires, which going to have a higher diameter wires and a higher cost. So for much larger industrial applications, we use also some specified gauges that sometimes not even standard. So for example, if you are using industrial electrical applications, you might have some weird gauges that you will be installing, but you don't have to worry about that as an IT professional. What you should be worrying about as an IT professional is the gauge about 20 to 28, which are basically smaller diameter core wires compared to gauge 18, 16, 14, 12 used in the electrical system. Please keep in mind, this is one of the places that some new students get confused about, or like the people who are new to IT get confused about. The smaller the AWG gauge, the bigger the conductor diameter. Do not get confused about this during an exam. You may get these exam questions on your, whatever the exams you are taking. So keep in mind, smaller is bigger, bigger is smaller. That's why the electrical wires have a smaller AWG compared to data communication wires. So the data communication wires are actually diameter wise smaller compared to electrical, but have a higher AWG, or the American wire gauge or gauge, because the gauge is always opposite. You need to think opposite, right? Keep that in mind. Why it is opposite, I can prove it mathematically why, but I'm not going to go into that detail here today, but keep that in mind because they do show up on exams. So let's look at the gauge and categories of cables. So Cat 8, Cat 6, Cat 6A, Cat 5E, Slim Cat 6 and Ultra Slim Cat 6 all have different gauge types. And this does matter in certain applications. For example, I'm not comfortable using a slim Cat 6 cable on a device that uses a very high voltage of power over Ethernet. I would not use that. Like, let's say we have everything wired in Cat 6 regular cable with 23 American gauge, and I'm not going to use an ultra slim Cat 6 cable of 32 American gauge for the last patch cable to install a very high power drawing power over Ethernet cable, because I don't feel comfortable that's going to work properly. So that's why you need to take into account what type of cable you buy. So the Cat 8 have a 22 gauge, Cat 6 have 23 gauge, Cat 5E have 24 gauge, and so on and so forth. And you can see the diameter goes down as you go down this list, and as a result that that the Cat 8 cable would have a bigger diameter of solid core or a core inside compared to Cat 6 cable. So because of the diameter going down as you go down here. So again, as I mentioned, for me, when I'm installing cables, if I have to use power over Ethernet with a very high power drawing higher end spectrum devices, I usually go with Cat 5E non-slim or Cat 6 non-slim cables because of the gauge difference. So does this have an impact on your data transmission? Yes, it does. It does have an impact. How do I know this? Because you can simply by looking at it, you can see the Cat 8 cable have a 22 gauge compared to Cat 5e have a 24 gauge. That means by going from 22 to 24, you basically reduce the diameter and hence reducing that capability. However, the Cat 6 regular cable have 23 gauge, but Cat 6 Ultra Slim have 32 gauge. So how is this even possible? The reason for that is the gauge is not directly proportional to the data transmission rate. Keep that in mind. The gauge of the wire is not directly proportional to the data transmission rate. That's why you can have a Cat 6 cable with 23 AWG, and you can have a Cat 6 Slim Ultra with a 32 AWG with a even smaller diameter. So keep that in mind. So while I'm more comfortable with using regular cables, like it's not the data transmission rates are not directly proportional to that of the gauge. What really matters is a category, because remember, category will guarantee minimum standard of operation, and that's what we are interested in as cable installers. Again, you can use Ultra Slim Cat 6 cables for power over Ethernet applications. It's just I don't recommend using that. Because I rather have the thicker gauge wires especially for those ones. One more thing I want to point out: if you pick a wire that is really low gauge for an application, that means you're going to have a thicker diameter cable. If you pick a wire that have a very high gauge, that means you're going to have a thicker core diameter. That means the thinner one most likely to produce more heat, especially in PoE applications. So thinner wires gonna have a more heat because of the wire is thin. So keep that in mind. Again, I will go into detail on a different lecture, but for now, just keep those in mind. Now we're gonna discuss jacket rating. So we're gonna switch gear. We're gonna discuss something called jacket ratings. So jacket or sheath is the one that goes outside the cable. Okay, so the jacket is the outside the cable, and there are different ratings associated with your jackets. Those include CM, CMG, CMR, CMP, and CMX. So I typically use the CMR, CMP, CMX, but some people also may use the term riser, plenum, and outdoor because of the use case scenarios. So CM/CMG are communication general purpose cables. They are used in patch panels, in-room cable runs, and not ideal for using risers and plenum. Plenum is basically ceiling space, as I was talking about. The ceiling space, if you're pulling wires in the ceiling space or duct space, those are called plenum spaces. And CMG are not typically recommended. You can use it, it will still work, but they are not recommended. Also, this can be a regulation or code law break if you actually use in plen spaces. So keep that in mind. Plen spaces, I believe this is pronounced plem, not plenum. Plem spaces. So keep that in mind because it may be not fire. It could create a fire safety issue. So keep that in mind. You don't use CMG typically on those confined spaces. You can substitute these with CMR or CMP as well, because they are okay to use as substitution, because obviously this is the lowest type, so going any higher would be fine for substitution. Riser, also known as CMR type rating, used for communications. So a riser is a vertical space, typically inside walls, between walls. So if you're pulling cables between walls to a wall plate, CMR cable is typically recommended, and those are used for in-wall insulation and maybe required due to insurance or contractual clauses and also legal reasons. As I mentioned, legally in most parts of Canada you can use CMG cables in phlegm space, but you can use CMR cables, and the substitution going to be CMP because that's the next level up, and you can't use or CMG here because that's going to be next level down, so we can substitute CMP. CMP, also known as PLEM cables, those are a communication plenum space, which is the space above the floors and typically occupied by heating and air conditioning ductworks. And you can put some of these cables inside the ductwork too. In most scenarios, it won't be any illegal. It would be fine in terms of code and law, as long as you use the CMP type cables. So the air ducts and PLEM above and below the floors and may be required due to insurance contractual clauses as well as a legal requirement for your jurisdiction. So keep that in mind. Also, another thing, if I have a choice of putting a cable right next to or inside a heating duct versus a cooling duct or an air duct, I will always pick the air duct or cooling duct over the heating duct. Even though the CMP cables are maybe rated to even go inside the heating ducts, just to keep it cool. Why would you want to put a cable when you have a choice of putting in a cooling duct or an air intake duct when why would you want to put it inside a heating duct, right? So I always do that. In my house, I actually try to separate the cable as far away from the heating ducts as possible, so it does not touch in the heating duct, just to be safe, even though I'm using CMP cables in my house. Then we have the outdoor CMX cable. This is the most expensive cable out of all of these types of cables here, and these are outdoor rated cables, typically have low density polystyrene, LDPE, which I'm going to discuss in my next few slides, and it is used for exterior insulation and can be buried or exposed to moisture, UV light, etc. And the cable run up to about 50 feet before you need to be terminating those cables. But you can get an expensive 100 feet cables nowadays. I saw in the market, you can buy it, but the cost gonna be significantly increased. And there is no substitute to CMX at all. Like, you can't substitute this to anything else above here. So we're gonna discuss special applications. Special applications includes the power over Ethernet, which I have discussed quickly a couple of times, limited power applications or LP, outdoor ratings, PLEM spaces and risers, which I also talk about, and one thing that I have not discussed, which is the antibacterial cable. Now you might have the question, what the hell is an antibacterial cable? I will describe that quickly here so that you have an idea. So let's discuss the power over Ethernet. So PoE, or power over Ethernet, is a type of networking devices that draw power via Ethernet cable. Either you are using the PoE injectors on the other end, or you have a switch that is capable of supplying the power through the port itself. Now, those include things like access points, security cameras, sensors like the security sensors, IoT devices like Internet of Things devices. Those include like things like humidity testers, detectors, temperature detectors. IoT devices also include the lights that turn on when you walk into the space, for example. So those kind of etc, etc. So because these cables are drawing power, that's why it says power over Ethernet, PoE. You need to make sure that the type of cables that you're using can handle the type of power it is drawing. For most security cameras, sensors, and IoT devices and access points, most Cat5e and Cat6 cables are good enough. It's going to be fine in any manufacturer. It doesn't really matter. What may be a factor that you may want to look into manufacturing quality of your cable with the PoE is that if you are putting cables in industrial applications where the PoE power draw is much higher, and you are putting cables outside the building where it is exposed to elements with power over Ethernet. So keep that in mind. You need to buy good quality cables, especially with power over Ethernet. We are putting outside in industrial applications as opposed to home or inside building applications. Limited power or LP applications, those are introduced by UL in 2015. UL is another standardizing body, and that supports something called PoE++ applications with over 60 watts. Even though it's called limited power applications, what that do is it support a PoE++ application that can have more drawing of power. So you can speak to your cable manufacturer when you're buying for your customer before you purchase it, to make sure that it fits for your need. Outdoor ratings, direct burial and aerial. So there are aerial cables as well. So what are the difference between a direct burial outside cable and aerial cables? Basically, direct burial is basically you can take the cable and without putting any additional jackets or anything like that, you can simply direct bury the cable. So if I have to take Ethernet cable from my house to my separated garage in my house, I will buy a direct burial cable. They are safe, they are easy to use, there are nothing to worry about. Things like lightning strike, for example, is less likely to happen on a direct burial cable than an aerial cable, and I would go and buy an direct burial cable. Direct burial cables are expensive, but it does the job. It is cheaper than actually sometimes putting a tube or a cable in the mud or in the soil. And also direct burial cable have special coatings that will not degrade when exposed to things like soil. Aerial cables you probably seen in infrastructure situations where companies would put aerial cables on poles. It's just like electrical cables. So if you go to let's say if you go to Amazon warehouse or if you go to Google data center, they probably have some aerial cables that going across to their for example their security cameras. So the security cameras is outside and they don't want to bury the cable for whatever the reason, and they pull the cable in the air, and that would be aerial rated cables. So keep that in mind. Again, I already discussed the flame spacers and risers. You need to make sure that you buy the proper cable. And finally, the antibacterial cables. Not a very popular cable, but this type of cables are also in use in specific situations. For example, if I am actually installing exposed cables in let's say in a hospital environment or a laboratory research, biomedical or a chemical laboratory research environment, my customer may ask me to install an antibacterial type cables. Those are cables that are like any other Cat5e, Cat6, Cat7, Cat8 cable, except the outer coating will have a special coating or a jacket. That jacket is rated for antibacterial cables. Antibacterial cables also do another thing, that is some of these cables with PVC and other jackets, if you expose to things like let's say like sanitizers, the cable jacket will degrade really fast. Like if you are working in a hospital and you have a patch cable that connected to a laptop, and every single time a medical doctor or nurse comes in and clean that patch cable with a antibacterial chemical, that patch cable jacket could wear out. But with the antibacterial specialized cables that are designed to be used in this kind of environment, you can keep using the the chemicals to clean the cable, and cable jacket will not degrade. So that's why we have these antibacterial specialized cables. Again, use case scenario, as an IT professional, as a technician, as a network cable installer, you need to discuss this with your customer and use it accordingly. So keep that in mind. So what should you choose, right? So again, you need to discuss with your customer about the or clients about the budget. So if the customer or client have unlimited budget, you can put Cat8 cable if you wanted to. Cat8 not even properly standardized yet. But if you want to go to the best standardization, you can go to, for example, Cat6a is pretty much well standardized right now. So if a customer is willing to spend that money, you can go ahead and do that. So if you're building a new house, for example, and that house comes with some network cabling installations, you can request the cable installers to install Cat6a cable, the house builders to install Cat6a cable over Cat5e cable. Right? If I'm a cable installer for a brand new house, that's what I would ask my client. Hey, do you have the budget for a Cat6a cable? And this is the cost difference. And if you're willing to go with it, we can go with the latest technology. So you need to discuss with your customer. You need to explain to your customer the differences. Explaining to an IT professional about differences, such as an IT team, is completely different ball game than explaining a different concepts associated with cabling to a management team or an end user. Some management teams have embedded IT technicians, IT professionals, engineers within them. Some management teams don't. So You don't need to be an IT person to be a manager of an IT team, for example, in many companies. So in that situation, you need, as an IT professional, you need to explain to the management team in their terms how those differences work and why they are matter. The same goes for explaining to an end user. If your end user is a client who is a home user, you need to explain to their level to understand their concepts associated with cabling. In fact, I found even IT professionals don't understand the importance of different cabling and cable types. For example, a lot of IT professionals I've seen sometimes incorrectly bury Cat5e cables in the ground. You can't do that. You need to have a direct burial cable, otherwise it's going to degrade. I've seen some IT technicians put Cat6 and Cat5e cables outside the building without any an exposure to expose the cable to the sunlight or UV light, and that's going to degrade the cable. So even IT technicians need to be educated on the differences in those cables. If you are a cable expert, if you are a cable technician, that should be your job. In terms of what is the difference between Cat5 and Cat6, or a Cat X and Cat Y, should I upgrade from Cat X to Cat Y? So Cat5e to Cat 6 or a Cat 5 to Cat 6a. That's all something to do with cost benefit analysis and how much data throughput you really need, how much bandwidth you need within that network. Can you mix Cat X and Cat Y, and if the network gonna work? The answer is yes, it will. You can have entire infrastructure built with Cat5e cables and then put the last bit in Cat 6. It's just going to create a bottleneck. And the same goes the other way around. You can have the entire infrastructure creating Cat 6a cables and you can have Cat5e on the last bit. No problem. It's just going to create a bottleneck. All Cat X, Y, Z cables are the same? No, they're not. So basically, if I get Cat5e cable from one manufacturer and Cat5e cable from another manufacturer, maybe one cable is significantly cheaper than the other cable, even though both are rated as Cat5e cables. If you get, like, for example, if I get two Cat5e cables from Amazon, for example, and one is really cheap, one is really expensive, even though the same length and everything is same, there may be a reason why it is that. Maybe the jacket of one of the cable is cheaper than the other jacket. The other jacket is made out with better material compared to the jacket of the other cable. Remember, what this categorization is doing is it is categorization. It is basically guaranteeing a minimum standard use case scenario. It is basically guaranteeing minimum bandwidth, guaranteeing minimum quality of data transmission. It is not guaranteeing the outer jacket. It is not guaranteeing how the outer jacket will be built, for example. So if you see two Cat5e cables, one is $30 more expensive than the other, there may be a reason why. So keep that in mind. Not all Cat5 cables, not all Cat 6 cables are created equal, even though they are rated equal. So keep that in mind. Rating only give you a guarantee of minimum bandwidth and transmission rate and use scenario for the packet switching. It is not guaranteeing the cable quality, the quality of the outside of the cable, for example. Do cheap cables work just as well? Yes, in most scenarios, the cheap cables works just as well. But I always make sure I buy the good quality cables from a well-known manufacturer if I'm installing cables in inside wall space, inside phlegm space, like the inside the ducts, etc., just so that I don't have to go back and rewire the whole building again because I bought cheap cables. So keep that in mind. So rules of thumb. For business and enterprise, it is all about the technology and cost versus benefit analysis. No business gonna go out of their way and reinstall Cat6a cable by replacing Cat5e cables unless there is a direct benefit to that business. Unless the business management people are stupid. There's no reason to waste money. for something, just to get the latest technology. So for the business and enterprise, it is all about the technology that they use inside the building and the cost versus benefit analysis. If it is a technology company that use the highest speed, highest technology, highest internal communication systems, they might ask you to upgrade their cabling infrastructure maybe every decade, maybe even that, but for most business, not even that. So that's what I mean by that. I know there are buildings in Calgary, for example, Calgary, Canada, in engineering and technological industry, they still use Cat5e cables from a decade ago, or Cat5 cables from a decade ago. So keep that in mind. So for the businesses, it's all about a cost versus benefit analysis and the technology they use. For consumers and home user scenarios, it is the maximum internet download speed. I'm telling you this because majority of internet connections in the world are asymmetric internet connections. In Canada, all cable internet and all satellite communication internet, and most cases, almost all network connections are asymmetric, except in some service providers, ISPs, have now started to offer symmetric internet. So what is asymmetric internet? What is the symmetric internet? Asymmetric means basically your download speed is faster than your upload speed. So all of us probably have in North America 100 megabyte per second or gigabyte per second download speed, but most of us have upload speed maybe maximum 50 megabyte per second. The reason for that is for majority of internet applications, what really matters is the download speed, not the upload speed. So what we are looking at is the asymmetric speed. So when you are speaking to your end user or client, what we really need to focus on is the download speed, because download speed is much faster. For example, if your user come to you and say, I have an internet connection that have 100 megabyte per second upload speed, 1000 megabyte per second or 1 gig download speed, what you really need to look at that download speed, because these are asymmetric internet, not the upload speed. So keep that in mind. So that's what I mean by maximum internet download speed. For most consumers and home user scenarios, Cat5e and Cat6 is more than enough for gigabit Ethernet download speed for asymmetric or even symmetric internet, as long as the symmetric internet is no more than 1000 megabyte per second. So keep that in mind. The reason why I talk about all this download speed, because most of the internet connections are asymmetric. I have never in my life have come across an internet network connection, ISP connection, which is asymmetric, where the upload speed is faster than the download speed. So that's why I always focus on the download speed. I never seen somebody having a faster upload speed than the download speed. So the bandwidth and the speed of download is what really matters. You also need to take into account the current local area network equipment. For example, if your home user or a small business user have network attached storage with 8K or 4K videos that they use, or a CAD files, for example, they have very large engineering CAD files on a NAS, network attached storage, make sure that you put at least Cat5e cables within the building, as well as think about putting in Cat6 cables at that point. Because internal network connection going to be much faster than the internet connection, and your user will use it, because for 8K streaming from a NAS will use the entire bandwidth if given the opportunity to use it. So keep that in mind. Also, you need to think about future internet and equipment needs of the customer. So if you are working with a small business or a home consumers, where they are telling you that, hey, my son going to install a NAS within next few weeks, and we're going to put all our family videos in 8K or 4K in there, and we all want to watch it. Don't put Cat5 cable. Put at least Cat5e cables or Cat6 or higher, and explain it to the customer and why the cost is higher and the benefits associated with it. So those are the rule of thumb that I can give you. And with that, that will bring us to the end of this lecture. And if you have any questions or concerns about anything that I have covered in this lecture, please feel free to reach out to me. Until next time, please thumbs up this video and subscribe to my channel, and have a nice day.